Okay, we're gonna work on this factor by grouping. Let me give you another procedure. Factor by grouping is based on what we did before. It's based on factoring out the greatest common factor. But notice a couple of things here for factor by grouping. You're going to have 1, 2, 3, what? These are 4 terms. Okay? So when you have 4 terms, typically it's going to be a factor by grouping scenario. So there's 4 terms. So for all these problems, you're going to have 4 terms because they're teaching you a technique called factor by grouping. So notice that there's 4 terms. Okay, so that's the first thing. But what I also want to say to you is this. The grouping portion, we're going to group the first 2 terms together. This is the first 2. And we're going to group the last 2 terms together. Okay? So I would say this is my first group. Here's my second group, and they're both groups of 2 terms. 2 groups of 2 terms each. Notice there's 4 terms here. Okay? So here's what you're going to do for each group. So if you want it in steps, I should say the following. Maybe step 1. If you want to describe what to do, I'm going to say factor out the greatest common factor, the GCF, for each group. Okay, now here's what this looks like, right? So for the first group, here's my first group. Okay, here's the second group. What's the greatest common factor for the first group? If I told you, if you worked on did you work on this homework here? Factoring out the greatest common factor homework? So if you worked on those problems, this is what it's going to look like, right? What's my GCF here? Isn't my GCF for the first group just x squared? Okay, you guys okay with that? Now what's the quotient? So when you did this homework the other day, right, or yesterday, the quotient's going to be x plus 8, right? So this is factoring out the greatest common factor for that first group of 2 terms. Okay, so this is kind of what we did yesterday. Remember, we said we're going to take x cubed plus 8x squared, and we're going to divide that by the greatest common factor of those first 2 terms, x cubed and 8x squared. We get this thing called the quotient, right? This is our quotient. So we get x cubed over, sorry, it's not x cubed, it's x squared. X cubed over x squared plus 8x squared over that x squared, and you get x plus 8. That's our quotient. Here's the quotient here. And over here, we have the greatest common factor. So what you just did was you factored out the greatest common factor for those first 2 terms. And that's what you did first right here. Right? Okay? Now we're going to do it for the next 2. We're going to do it for the last 2, which is the second group. What's the greatest common factor here for 2x and 16? 2. So put the 2 here. What's your quotient going to be?
X plus 8.
Okay, it's going to be x plus 8. So if you guys forgot from yesterday, if you said, well, how did you get the x plus 8? Well, I took the 2x plus 16 divided by my greatest common factor of a 2, right? Like over here, we divided by x squared. And we're going to get what we call a quotient. So you got your 2x divided by 2 plus the 16 divided by 2. This gives us the x plus my 8. So I get an x plus 8 here again as well. Okay, you guys okay with that? This is factoring out the greatest common factor for the first 2 groups. Now, notice this. What sign here is between my groups? It's kind of covered up there. I'll erase the blue. Blue's gone, blue's gone. What sign is that? Is that addition? So you're going to have to keep then that addition sign. You're just bringing that addition sign down. Okay? So this is what they mean by factoring out the greatest common factor. Anybody have any questions on that? Okay, I'm going to erase this work here. I'm going to erase the quotient work. because we worked on all of that the other day. But that's the quotient work. Now remember, greatest common factor, quotient. So if you know how to do this, you're almost done. Now here's what I'm going to say to you for step 2. Step 2, you're going to factor out the common term. Okay? Factor out the common term for what you just did right here. So I'm going to point out to you guys, what do you think's common for down here? Let me erase this. Right? I have an x squared term, I got an x plus 8 term. I got a 2 term, I have an x plus 8 term. Which term is common? Good. So here's my x plus 8. Common meaning it's in both. Okay, you okay with that? So x plus 8 is common. So here's what you're going to do. You're going to write down that common term of x plus 8 right here in parentheses. Now, when I say factor out the common term, let me tell you what I really mean by that. Okay? So write it down here. You're going to find a new quotient. Since x plus 8 is common, we're going to factor that out. That means divide the problem by x plus 8 and really find a new quotient. And if you guys notice, like before, you get x squared plus x plus 8 over that x plus 8 plus 2 times x plus 8 over that x plus 8. And that's our new quotient. So we're going to multiply that factor of x plus 8 with this new quotient here. Let's see if you guys can figure out what that's going to be. What do you guys get canceling here and here? The x plus 8, right? What about here and here? What do you guys have left? Don't you have the x squared term right here? And don't you have this plus 2 term right here? Isn't that my new quotient now? Okay? So let me remind you, if you're going to factor out the common term here is that x plus 8 term. You're going to factor that part out. We already said this is what we're factoring out. To get the new quotient, you divide this whole problem by x plus 8. But if you're really awake now, you might recognize something here. What do you guys see? Isn't there an x squared term here and a 2 here and a plus? Isn't that what you got down here for your new quotient? So what you could do here is this. Simply replace that new quotient now, right, with that x plus 8 or x plus 2. What you see here is your final answer. It's x plus 8 times x plus 2. So
X squared.
yeah, there's an x squared, sorry. X squared plus 2. Thank you. So this is your two-step process known as factor by grouping. And we're going to do this process for every one of those problems. Remember, 2 steps here. Group the first 2 terms with the last 2 terms. Factor out the greatest common factor. That's step number 1. Step 2, factor out the common term. So this procedure we're going to use for all these problems, and we're going to see this over and over again. And you're going to see something special, and I'll point it out as you go along. So before we begin the others, does anybody have any questions on this before we start the others? So let's look at number 3 then. We go through this process. It's a simple process. Okay, as you guys know, you probably have to do how many of these? 500 of them? So you could do it in your sleep, right? X cubed plus 5x squared plus 3x plus 15. Okay, 4 terms again. So I'm going to write this down, 4 terms. What do you guys do? You group the first 2 terms and the last 2 terms, right? Factor out your greatest common factor. Factor out your greatest common factor. Okay. Greatest common factor of x cubed and 5x squared, what is it? What was it from yesterday? X squared, good. Okay. What's your quotient? X plus 5. Is that your quotient? Okay, you guys okay with that one? Now, what's the greatest common factor of the next two terms, 3x and 15? And then is that 3? Okay. What's the quotient? Okay, good. Plus, what has to go down here? Plus, good. Okay, that's your first step. Do you guys recognize anything that might be common? Right, what's common here? Anybody see anything common to both of these terms? Common meaning being the same. Isn't that x plus 5? Okay, is that common? All right, let's take a look at this. What am I going to write down? Write down that common term, x plus 5, and then what goes here? See if you're awake. It's going to be x squared plus 3, that's right. How do you know? Because if you were to go back now and divide by x plus 5, that common term, and you distribute your division, doesn't the x plus 5s go away? Right? And then you're left with here the x squared and the 3. So we're left with that x squared and 3. So what you can do is you don't have to go back and really divide that way at all. Okay? You don't have to go back and do that. Just recognize what's left, the x squared and the plus 3 there. You factored by grouping just by writing that down, just by looking at this picture, right? I'll put an eyeball here. Just by looking and identifying the common term of x plus 5, and you wrote down that x plus 5. And then you wrote down the other terms. In this case, it's a sum. You factored by grouping. You could go through the whole procedure, or you can go through this sort of shortcut. Okay? What do you guys think? Do you like the shortcut? Isn't that pretty simple to factor by grouping? It's going to be an important step in problems that we do in the future. So I'll bring it up. I'll tell you the problems that we have to do in the future may involve factor by grouping. So, you know, we have to do a series of these. X cubed minus 4x squared plus 4x minus 16. Okay. Again, notice 4 terms. I'm going to factor by grouping. Group the first 2, group the last 2. First 2 terms, factor out your greatest common factor. That technique, factor out greatest common factor. Greatest common factor of x cubed and 4x squared. What is that? Was that x squared? Okay. What's your quotient? X minus 4. Good. Greatest common factor of 4x and 16. What's the greatest common factor? 4. What's your quotient? Is that x minus 4? Okay, good. What do you guys see here? Plus. What goes here? Plus. Okay. Do you recognize what's common? X minus 4 is common. Is that true? So we're going to write down x minus 4. What's left? X squared plus what? 4. And you're done. Okay, pretty easy. So now you guys noticed why we had to do all the problems we did yesterday and factor out greatest common factor. That's a procedure that we learned already. If you learn this procedure, today you're just applying the procedure twice. Okay, and then you're seeing what's common, and then you're seeing what is left over. So let's take a look at number 7. We get x cubed minus 5x squared plus 5x minus 25. How many terms again here? 4 terms. Okay. Group the first two, group the last two, factor out the greatest common factor for each one. Now, after a while, I'm not going to put down that phrase, right? I'm just going to group them, but in the beginning here, we'll put the phrase down. Greatest common factor of x cubed and x squared? X squared. What's your quotient? Okay. Good. 5x and 25, greatest common factor? 5 and x minus 5. Okay. What's our sign here? Plus. Put your addition sign. Anything common? X minus 5 is common. Is that true? So you write down your x minus 5. What was left over? X squared plus 5. And you are done. All right. You guys okay with that one? Pretty simple? All right. Let's look at number 9 here. X cubed plus 2x squared minus 4x minus 8. Okay. So again, I'll write it down. 4 terms, group the first two, group the last two. First two, last two. Okay? Factor out the greatest common factor. So for the first two, what's your greatest common factor? X cubed and 2x squared. What's that GCF? What is it? X squared. Good. What's your quotient? Is that x plus 2? Okay. All right. Now look at the last two terms. What's your greatest common factor here? 4x and 8. What's that GCF?
4.
It's 4. Okay. And then what's my quotient? X minus 2. Is that right? Okay. Now, what do you guys notice? What's different about this problem than what you had before? Is there anything different?
The signs are different on that.
Yeah. If I asked you for the second step here, what we have to do now is I said, what's common? And what you've seen in the past, what was common was you said, oh, here's an x plus 2, but then this other term, that's not an x plus 2. Right? This other term over here, that's x minus 2. That's not common. So I'm going to put this in our notes here so you guys write this down. This is not the same. Okay? They're not the same. In order to do the last step, to factor out the common term, this must be the same. So if we go back and we go, okay, I wonder what happened, what went wrong? How come these two things are not the same? Well, let's take a closer look. Yeah, exactly. You see what the sign is here between the two? That's a minus sign. So I'm going to have to bring down that same sign, that minus sign. Okay, you guys okay with that? Now notice this. I'll say here's by the way. On the left hand side, I got x squared plus x plus 2. On the right side, if I FOIL, and I'm not saying you FOIL here, this is not a part of the process, but if I were to FOIL, don't I get negative 4x, and then I get negative 4 times a negative 2, doesn't that give me a positive 8? You guys see what I'm saying? This portion right here is not the same as what we have right here in our problem. The only way I can make those portions the same is if I change the sign from a negative here to a what? Positive sign. Now double check. By FOIL, negative 4 times x is negative 4x. Negative 4 times positive 2. This makes this now here actually a negative. So now they're the same. Okay, so take a look at what just happened here. Let me summarize this. Okay, let me get rid of this work. To summarize what just happened for you is this. You have here a negative sign. You're going to have to put a negative sign down here. Now when you factor your greatest common factor from the last two terms, that's going to always change this sign here, because you have to account for the fact that this is a negative sign. And so notice what actually happens. X plus 2 and x plus 2, they're now common. They're the same. So we have to have that common term here. These have to be the same because when I factor out my x plus 2, the common term, I have to have both x plus 2's there. And this is going to be now x squared. What's my sign? Minus a what? 4. Okay? So that's going to always happen when you have a negative sign there. Okay? It'll always happen. You're going to have to change this the sign that follows. So I want to point out to people the following. Whenever you have that negative sign, I'm going to say to you, always be careful.
Like when you're subtracting polynomials?
Yeah. Yes. Exactly. You're going to have to be careful with that negative sign. You have to account for it. It's going to always change the sign over here to the right. It's going to change the sign here. All right, let's try another one here so you guys can see what I'm talking about. All right? You're going to have to get used to that.
So whenever you see a negative sign, you got to...
You're going to have to change that second sign. So let's see another example so you guys, like I said, you have to get used to that. You got x squared here. Take a look. X squared, sorry, x cubed. X cubed plus 7x squared, number 11. Minus 7x minus my 49. I'm going to say to you, let's take a look at this. There's still 4 terms. It's factored by grouping. Okay. Group the first 2 terms. Group the last 2 terms. You're going to factor out again the greatest common factor. Factor out that greatest common factor. They really mean that procedure, but be careful. This is what? Subtraction between the 2. All right, we're going to be careful with that subtraction. Here we go. Greatest common factor of x cubed and 7x squared. What is that? That's x squared. Good. And the quotient is x plus 7. Okay. All right, now the last 2. 7x and 49. What's your greatest common factor? You can say 7, and then my quotient's going to be x and 7. Right? 7x divided by 7 is x. 49 divided by 7 is 7. I know my sign here has to be subtraction. Is that true? What sign comes over here now? Is that positive or is that negative? That's a positive. Is that true? Now be careful. Let me go back. Some of you guys are going to say, hey, it was negative there. I should have a negative sign right here, right? It should be negative. You're right, but because the first term out here was positive, let's change this color. Well, let's go back here. Sorry. This term here is already negative. So when I brought down my negative sign, the only way I get a negative 49 here when I multiply. Oops, go back here. If I were to use FOIL, negative 7 times x is negative 7x, but negative 7 times a negative 7 is a positive 49. We're going to have to change the sign. Has to be plus. Now notice what happens. Negative 7 times positive 7 does give me that negative 49. But more importantly, or I should say equally as importantly, aren't these terms the same? Aren't they common? Okay, so I'm not changing it just for the sake of changing it. But you're going to get the common term there, and you now have the common x plus 7 with your x squared minus 7 here factored. This is what you do when you have the negative sign. So if I go back here, and I want to summarize here. This sign's negative. That's negative. Okay? This sign over here, let's change the color. This negative is going to have to change to a what? A positive value. That's right.
Can you, when you see the problem like that, can you just go ahead and change it
Yes.
right away instead of doing all that other stuff there?
Absolutely. You can change it right away. So when you see it, like when I tell the people, when I actually do this, and I'll show you what I'm talking about. When I actually do it myself, I change it right away. But I'm going to go through every detail with you so you guys can understand what's happening, because sometimes people think you just change it for the sake of changing it, and you're not. But yes, you can. The answer is absolutely. Anything that you can do there to help yourself, you do. Yes?
And the problem when you're solving, you want to make sure that it's the same. But when you solve for the answer, it doesn't have to be correct. Because this is X.
Well, if you're going to do the last step,
Right.
you have to have this term and this term
Match.
be the same. Yes, exactly the same. And we call that being common. And they will.
Right. And then in the final answer.
Final answer, notice you have,
Never mind.
yeah, you got it there. Question?
Basically, just like decide which one will be like you switch your like your addition and subtraction, right? Like
Well, this last term right here will always be switched. That last term right here. That one, that's the one that will be switched.
So like if anything, like it will still give you the same answer if you put the negative same and the things inside and the positive stuff, right?
No, keep your negative sign outside. Keep this negative.
Yeah, but like that's the way to like finish with steps. But like it will still give you the same thing if you put the negative inside.
No, it won't. Then the first term is going to be off. So just keep that negative sign here, and just change the second sign. Just keep it simple. Keep that negative sign and change the second sign. Let's see if the next one is something you got to be careful about. And when you're doing this factor by grouping, yeah, let's try this one. 13x squared. I'm sorry, keep doing squared when it's x cubed. X cubed plus 6x squared. This is minus for number 13. 3x minus 18 here. Okay. Take a look at that. 4 terms. Okay. Group the first two, group the last two. Let's notice though that there's a subtraction there, so I'm going to be careful. That's all. So I'll show you exactly what I'm talking about when I do it. So I'll go through it and say, you got x cubed, you got 6x squared. Greatest common factor is your x squared. The quotient's x plus 6, and that's factoring out the greatest common factor for the first group. Now the second group, I got 3x and I got 18. And the greatest common factor here is 3. My new quotient is x and a 6. Okay? I don't even pay attention to that sign. Now I go back and I go, okay, this is that minus situation. Let's get this out of the way. Okay. This is the minus situation. So you might say, well, what does that mean? I'm going to bring down that negative sign, always. And then I remember these are going to be what? Common. This is going to be what? Plus. Now, I always double check. And you say, what do you mean? Yeah, is it true that negative 3, let's go change this. Negative 3 by the distributive property times x is negative 3x? Yes. Is it true that negative 3 times positive 6, does that give me a negative 18? Right? You guys see, remember this is negative. Right? Negative 3 times a positive 6 does give me a negative 18. So I know, I'm on the right track. Okay? Now, when they first give you these problems, they should give them to you this way, factor by grouping, where it works out. Okay? So it does, and that's what I did when I wrote these problems. I said, let me give you problems where it works out. That doesn't always happen. And if it doesn't work out, even after you check here, you just say not factorable. But when you first learn any process, I think it's always best to show people, what's factorable. And so I wrote it that way. And now you say, I got the common term. So what's your final answer? What's the last step? What's common is x plus 6. Is that true? And what's left? X squared minus 3. Notice, in some ways, there's only 2 lines here of work for factor by grouping. Okay, now this is a scary problem because it has that subtraction between the 2 groups. All right, you guys okay with that one? Okay, let's try the next one. Let's see what happens in this one here. 15. But these are kind of some two factoring strategies here that are going to be important for us. 15, x cubed plus 2x squared. This one's plus 6x plus 12. So again, notice, I'll write it down. 4 terms. Maybe for the last time I'll write that down, and then we group the first two and we group the last two. Is that right? Okay. Now, greatest common factor, the first two terms, the first group, x squared. What's the quotient? X plus 2. Good. Greatest common factor for the next two? 6. What's the quotient? Good. What's my sign here? This is plus, so this is going to be a plus. No worry. No big deal. No worry. It's plus. Is x plus 2 common? Sure is. Write this as x plus 2 times x squared plus 6. You are done. 2 steps to factor by grouping. Okay, so you guys want to know, definitely factor by grouping in your what? In your sleep. Let's try 17 here. We got x squared plus 8x plus 2x plus 16. Okay, again, 4 terms. Group the first two, group the last two. Okay. X squared and 8x. What's your greatest common factor? Is that x? What's your quotient? X plus 8. Good. Greatest common factor for these next two terms? Is that 2? Okay. What's the quotient? X plus 8. Is that right? This is addition, so this has to be addition. Good. Any terms common? X plus 8 and the x plus 8. Is that true? So tell me, what's the last step? What's the last step? What do I write down? The x plus 8, the common term, and then you write down the what? X plus 2. Good. Yes?
Right there, does it matter if they're like terms, the 8x and the 2x at the beginning?
A good question. Very, very good observation. You're actually doing a technique, right? And you say, what's this technique? This is called factor by grouping. Okay? So your instructions are going to be, hey, factor this by grouping. But you're absolutely right. If the instructions were to say to you, combine like terms or add, right? Then yes, you can say, oh, you know, the 8x and the 2x gives me 10x, and you're done. So that's a good observation. Those terms are like, yes, you can add them, but that's not what they want you to do. Okay? What they want you to do is practice this technique called factor by grouping. Yeah. So always remember, read the instructions. It tells you kind of what to do. I mean, I like to think of it as a recipe. I'm learning this recipe, right? Yesterday we had the factor out greatest common factor recipe. Today is factor by grouping recipe. Follow those instructions and you're fine. But you're absolutely right. You can combine those terms, but they never asked us to. And really what I'm showing you here when I wrote these questions is that this is part of another factoring procedure that you'll see in the future. You know, one of the steps in another procedure is factor by grouping. So these are kind of common to what you'll see in the future. So what I wanted you guys to do with some of these problems is get this practice in, because it's, for the most part, a lot of this is, muscle memory. You know, you're going to have to go through, I know that says 18, let's change it to 19. We're going to just work on the odds. It's somewhat muscle memory, but you have to go through the procedure repetitively. And I mean, even this one, let's see what happens here. I wrote this a while back, and yes, you can combine like terms, but the procedure or the idea is you just factor by grouping. Those are my instructions. So let's group the first two. Because notice we have 4 terms. First two, last two. Factor out your greatest common factor. So for the first two, x squared and 4x, what's the greatest common factor? X. What's the quotient? X minus 4. For the first two terms, what's your greatest common factor? 4. What's the quotient? Okay. Notice this is plus, so I should put a plus. Okay. Okay, anything common? X minus 4, common. So we're going to write down x minus 4 times x plus 4. And you're done. Number 19. So, you know, they're trying to get you to work on this tool. So let's see, 21, we get x squared plus 6x minus 3x minus 18. Group the first two and the last two, but I'm going to warn you. What do you guys notice? Subtraction sign. Okay, just from the beginning. We just, you know, we don't have to panic. It'll be all right. All right. Factor out your greatest common factor. First two terms. What is it? X. What's the quotient? X plus 6. Last two terms. 3x and 18. 3. What's the quotient? X plus 6. Oh. Is it x plus 6? Let's double check. I bring down my subtraction sign. Double check. Is negative 3 times x negative 3x? Yes. Is negative 3 times positive 6 negative 18? Yes. We're on the right track. Okay, good. Common x plus 6, and we can now write our final answer. X plus 6 times x minus what? 3. And there you go. Pretty good? Okay, see, you're getting the hang of all this. Not too bad. 23. Okay, let's try some harder ones, I guess. 2x squared plus 8x. Let's see if this is harder. Plus 3x plus 12. Okay. Still 4 terms. So we factor by grouping. That's our instructions. Group the first 2 terms. Group the last 2 terms. What's happening here between my 2 groups? I got addition, so I don't have to be that careful, right? All right, good. Greatest common factor, 2x squared, 8x. What is it? Is that 2x? What's your quotient? Is that x plus 4? Remember, when you take the greatest common factor, take the GCF separate. The numbers 2 and 8, GCF is 2. X squared and x to the smallest power, so it's 2x. So, okay. 3x and 12, what's your greatest common factor for 3 and 12? 3. Remember, x isn't even common, so you're done. Right? GCF here is just 3. What's your quotient? X plus 4. What sign's between the two? Addition. Do you have anything common? You guys see anything that's common? You see the x plus 4, so you're going to get 2x plus 3 times x plus 4. And there you go. What do you guys think? Is that fine? Okay, everybody okay with that one? All right, let's try number 25 then. 25. Okay, 25. 3x squared plus 9x plus 4x plus my 12. Group the first 2 terms and the last 2 terms. Okay? Greatest common factor of 3 and 9, isn't that 3? X squared and x, isn't that x? Okay. What's the quotient? X plus 3, good. Greatest common factor of 4 and 12. What is it? 4, good. What's the quotient? X plus 3. Common, common, this is plus, so bring down the plus or the addition sign. Final answer, x plus 3 times 3x plus 4. Really good. It's number 25. What do you guys think? Is that pretty simple?
A lot of steps.
A lot of steps? Well,
Even more with the other way. when you have to-
well, you're going to start to get used to processes that have more than 1 or 2 steps, and they're gonna show up in your problems here. 4x squared plus 6x minus 10x minus 15. Okay. Group the first 2 terms and the last 2. What do you guys have to notice though? Subtraction, so we're going to be careful. Okay, so the greatest common factor of 4 and 6, what do we know that is? Is that 2? Okay. X squared and x is an x, so my GCF is 2x. What's the quotient? 2x plus 3. Okay. The next problem, GCF of 10 and 15. You guys know what that is? Is that 5? Remember, x isn't even common, so we're actually done with that GCF. So x isn't even common. Okay. What's the quotient then? It's going to be 2x. 10x divided by 5 is 2x. 15 divided by 5 is what? Is 3. Don't forget to bring down the what? Bring down that negative sign. But then if I bring that negative sign down, what's the other sign? Isn't it going to be opposite of a negative, which makes it a positive? Is that true? Double check. Is negative 5 times 2x negative 10x? Is negative 5 times positive 3 negative 15? It is. So we have 2x plus 3 as the common term. So we're going to write this down this way. 2x plus 3 times 2x minus what? 5. We're done. Okay, let's try number 29 here. We have 5x squared minus 20x, or 10x, sorry, minus 4x minus an 8, number 29. All right. So 4 terms, group the first 2, group the last 2. Notice there's a subtraction sign. We're going to be careful. All right, we're going to be careful. So greatest common factor, 5 and 10. What's your GCF? X squared and x. Okay. What's the quotient? X minus, is it 5 or is it something else? 2. Good. That's my quotient. Now remember, if you have to go back on some scratch work and do your scratch there, there's no harm in that. 5x squared over 5x minus 10x over 5x. So you get x minus 2. There's no harm in actually going through the work. And I would even recommend you do it if you're learning this for the first time and you need the practice. Then go ahead and do every one of those steps. You're just going to be better for it. Now, what about the next set here? GCF of 4 and 8 is 4. What's your quotient? Remember, x isn't even common, so that can't be a part of your GCF. 4x divided by 4 is x, right? What's 8 divided by 4? 2. Now, you're going to bring down that subtraction sign. Now, what's the opposite of that negative sign? Positive. Can I distribute to double check? Negative 4 times x is negative 4x. A negative 4 times a positive 2 is a, check, negative 8. All right. Is that what we got here? Double check. Now, I got an x minus 2 here, and what do I have over here? I got x plus 2. Did we do everything correct? Did we follow the steps? Oh, okay. Well,
Factorable? Is it unfactorable?
well, what we say here is that these four terms are not what? Factorable. Okay, when you try to factor by grouping, we can't do it. Now, be careful. Like I said, when I first show people how to do this, I show them with things that are factorable. And then you can toss some of these in that aren't, and you just say they're not factorable. This is also known as being prime. We'll see these concepts in the future, but I want to show you now, just so that when you see that in the future, you know what that means. It's not factorable, it's prime. Okay. But we did everything okay here, right? So in your homework, in your textbook even, there are going to be some that work out like that too. They throw them in, you go, oh, I thought I knew the process, I thought I was doing everything right, what happened? You may have been, you may do everything right, but you got down here and it was, oh, they threw one that was not factorable. I guess just to keep you honest, to make sure you really know, but all right. So I did that too. 4x squared minus 6x. Let's see if this one's factorable. Plus 8x minus 12. Okay, group four terms. Group the first two, group the last two. GCF of 4x squared and 6x, what was that? I think that's 2x, right? What's your quotient? What do you guys get for a quotient? Anybody know? 2x what? 2x minus 3? Okay. GCF of 8 and 12. What's that going to be? Is that 4? What's the quotient? Anybody know the quotient? 2x minus 3. And you're bringing down your addition sign here. All right. Is this common? 2x minus 3 is common. What's left? 2x plus 4. You're done. Okay, so it looks like this one was factorable because you got the common terms there. So what does that bring us up to? 33? All right, let's try 33. Get 9x squared minus 3x plus 6x minus 2. Okay, let's see what happens here. Four terms, group the first two, group the last two. GCF of 9x squared and 3x. 9 and 3, what's your greatest common factor? Is that 3? X squared and x? X. What's the quotient? 3x minus what? 1. Is that true? All right, 6 and 2, what's your greatest common factor? 2. What's the quotient? 3x minus 1. This is plus, so this is plus. Double check. Are we okay with that? Right? GCF quotient. GCF quotient. So if you didn't work on those problems yesterday, you guys want to try that out because that's happening with the factor by grouping. And then, do we have common? Is this 3x minus 1 common? Yep. Final answer, 3x minus 1, 3x plus 2. You have factored. I just want to make an observation or a note. I want to remind you guys, sometimes students ask this question. You guys didn't, though. Sometimes people say, do I have to write it in order like 3x minus 1 and 3x plus 2? And I'll say, no, you can write 3x plus 2 here times 3x minus 1 because the order in which you multiply doesn't matter. Meaning, you got this left term, this right term, or left terms and right terms. More importantly, you got this product between the two, so the order in which you multiply doesn't matter. So you can write it either way, just to let you guys know in general. And nobody asked that question, but a lot of times people do. So let's see, 35. Let's see what 35 is. 6x squared minus 6x. And then you have minus 4x. Well, sorry. It's plus 4x minus 4. All right. Group the first two terms. Group the last two terms. Let's be consistent. Greatest common factor is 6x squared and 6x. What is it? That's 6x. Okay, good. What's your quotient? What is it? It's going to be x minus 1. Is that true? Greatest common factor of 4x and 4. What's the quotient? X minus what? 1. Addition, addition. Oops. So you're going to bring down your addition sign, and let's double check. X minus 1, x minus 1. This is common. This is the same. What's your answer? X minus 1 times 6x plus 4. You are what? Done. Okay, so this is here. This is the work on factoring out the greatest common factor.